Hello, so this is an argument that the Earth is not flat. I want to hear attempts at rebuttals to it because I've been trying to get flat earthers to listen to this argument and process it and rebut it, and I went on the 24/7 Discord, I went on Nathan Oakley's show, they wouldn't even listen to it there. So I just want to hear your rebuttals, flat earthers, because I'm proving you wrong here, so that should matter to you. Okay, so my argument is basically this: I have two premises. One is that bodies of water obstruct distant objects most of the time, and the other premise is that a standard atmosphere bends light downwards. Now, I'll just give briefly some evidence to support these premises, or these claims. So let's look at bodies of water obstructing distant objects. Okay, so here we see the CN Tower, and you can clearly see that the sky dome is obstructed by the water. Where you expect to see sky dome, you see water. So the water is obstructing the distant object. Here's another picture of it. You can see here's the CN tower overlaid over it, and you can see the bottom third of the tower is missing. Water is obstructing the bottom of the tower. Here is a list of observations, or catalog of observations that I did. Basically, the first observation point is at the beach, and the second observation point is at the high elevation up on the bluff. And here's the pattern: landmass obstructed, landmass visible, landmass obstructed, higher elevation, landmass visible. You look from the beach, landmass is obstructed, go to the higher elevation, the landmass is visible. Here it is again: obstructed, visible. Here it is again: obstructed, visible. Here it is again: obstructed. I didn't go to the top, but you can see that the tip of it is there, so you can tell it's obstructed. Here it is again: obstructed, visible, although it's kind of foggy. Here it is again: obstructed, visible. Here it is again: obstructed, visible. I think you get the point. Water obstructs distant objects. Right, and just remember the top picture is from the low elevation and the bottom picture is from the higher elevation. So from the higher elevation we see the island, from the lower elevation we don't, and I got countless examples of that. Okay, so now the other claim I made is that a standard atmosphere bends light downwards. So in this picture here, what a photographer did was take pictures of the moon 6.5 minutes apart in the long exposure. And as the moon gets closer to the horizon, the distance between the moon exposures decreases. So you see it's 90 pixels up here between tip to tip here, but it's only 84 pixels tip to tip down here. So that means that the moon is slowing down as it approached the horizon, or in other words, it was being loomed up. Here's more. So, and here's, I just got to define the zenith angle here. So you have a zenith line here, and then you have a line to your object. And the zenith angle is this angle here, the angle between the zenith and the line to your observed object. And here's a citation from a book, Astrophysical Quantities, a book I found through Wikipedia. And here we go. It defines ZT is the true zenith distance, and ZA is the apparent zenith distance. So ZA is what you see, and for celestial objects. So you can see when we're at, say, for example, when an object appears to be at 75 degrees zenith, it's actually a little bit lower. It's 75 degrees and 4 minutes. So that means that the object is lower in your view. Or it means it's lower than it actually appears. Or you can think of it as like if the sun is down here, and if its true position is right here, it looks like it's up here. So the sun would be loomed up. That's what it says right here, right? If the true position of the sun is 90 degrees and 35 minutes, then the parent position is only 90 degrees, a little bit higher. So that's enough evidence to support my two claims, I believe. So now let's go into the argument. So the argument is basically this: assume the Earth is flat. That's our starting assumption. And I got a line here so we can keep track of the assumption that we've made. So then the first step is I use the fact that light bends down and the assumption that the Earth is flat. I take those two assertions and I conclude that, and I derive that light from all parts of a distant object should reach the observer on the surface most of the time. And that's the key of the argument, and let's just explain that. So since light bends down and the Earth, so we got our two assumptions here: Earth is flat and light bends down. See, the arc it's making is a downward arc. So if light bends down, light coming from the mountain, well, light from all parts of the mountain is going to reach the observer, right? Because think about the light coming from the bottom of the mountain. If the arc was a bit sharper and the arc went only in the middle of the ocean here, well, you just pick an arc that went a bit higher than that, and then that one would eventually reach the observer. And you can do that for all points on the mountain. You can choose for every point on the mountain, you can find an arc that intersects the observer. Right? If light bends down, you don't know how much it's bending down, but if it bends down, it will reach the observer. Another way to think of it is rays emitted from the observer. So the observer if you imagine the observer looking straight down, and then he tilts his head backwards up, gradually looking at each ray. The ray is going to go to here, then the ray is going to go to here, then the ray is going to go to there, then the ray is going to go to there, then the ray is going to go to there, then the ray is going to go to there, then the ray is going to go to there, and he's going to see the whole mountain. So light from all parts of a distant object should reach an observer on the surface most of the time. It's this first step there. And then, so if light from all parts of the distant object, and we're talking about distant objects across the ocean, by the way. So number 2, line 2 implies this. It implies that observer should see the whole object, right? You should see the whole object if light from all parts of it reaches you, you should see the whole object. So then, in other words, bodies of water should not obstruct distant objects most of the time. You should see it all, it should not be obstructed. In other words, so bodies of water should not be obstructed. But look what that implies. That implies, but we can bring in this premise here and state that again. So we state O, and bodies of water obstruct distant objects, and we have not O. Bodies of water do not obstruct distant objects. We have O and not O, right? But it says here, in other words, bodies of water should not obstruct distant objects, but bodies of water do obstruct distant objects. So we got O and O. So that's the contradiction. So now what do we do when we get a contradiction? We go back up to our assumption, and then we have implied the opposite of that. So it implies the Earth is not flat. So we see how we reason logically that the Earth cannot be flat based on these two premises. Now, what I'm looking for from the flatties is a rebuttal to this, because I can't get flat earthers to rebut it. Like, they're afraid of this argument. What are you afraid, or what? Come rebut the argument. What are you waiting for?